Hello, everybody. Good afternoon. Thank you all for accessing the webinar. The number is still counting up, but we're really glad that everybody is here and that we can actually engage or have a conversation with you and show you what we've been working on now that we're not at Jack this year. But obviously we'll be there in 2 months. This webinar will be launching our new product line called the Red Series. Which is an all-in-one solution for digital composite production. And we're really excited to share this with you. We'll do this in 2 ways. First, Martin will give a presentation, and afterwards we are open to questions, and we'll try to answer as many of them as we can. My name is Chester. I'm the CEO of the company. And I'm joined by Rene Roos, who is a lead software developer at Ansys, working on the composite simulation. And we've been very closely working together with them over the last months, who will also be there for any questions that you might have about simulation. And then also joined by Martin, our CEO, and he will kick off with the presentation. So take it away.
All right. Thank you, Chester, for the introduction. Hello, everyone. I'm really excited that so many people are joining for this webinar on our Red Series launch. And before I jump into the presentation, I quickly introduce to you the agenda, or basically the structure of the presentation. So first, I will go into the introduction part, where I will basically unveil the Red Series, introduce the Red Series. And then we have a middle section where we dig in a little bit and talk more about the product details. And in the last part, we talk about the product offering and also the availability of the system. And in the last, at the end, I think the total presentation will be around 35 minutes. So there will be also plenty of time for Q&A at the end. All right, so let's jump into the presentation. So to give you some context, carbon fiber reinforced composite materials are already heavily utilized in industry because the material is as light as plastic, but strong like metal. And we see applications in various industries. So aerospace is kind of like the industry where it originated from, but there's also other application fields in different industries like medical, all the way to different sport applications, leisure applications. And then there's a newer industrial field, which is called robotics. So robotics are all the new applications where you have kind of autonomous systems, which all have batteries. And this performance material is commonly perceived as being just lightweight and strong like metal. But there are also other features, mechanical properties, which are quite unique and for some applications quite essential. So that's why we listed some more here. So thermally stable, what does that mean? It's basically the coefficient of thermal expansion is quite low. So that's kind of an interesting characteristic if you have an application where you have severe temperature changes and you have to position something really accurately in this kind of environment. Just imagine an antenna in a really severe environment. So X-ray transparency, that's kind of interesting for medtech applications. So just imagine a surgical environment where basically your instruments are not visible on an X-ray scan. And then the last point here on that slide, corrosion resistance. Basically, it's not a metal, so there's no corrosion, but I think this is meant a little bit more in a broader sense that there's good chemical resistance of those materials. So now we have been talking about the material, a bit about industries, and this is just named a few industries. It's not all of the industries where we apply this performance material. Let's jump one step further, and we go now into the processing of those materials. So in a way, there are 2 worlds. One is the manual world, and one is the automated world. So if we first talk a little bit about the manual world, so there's a lot of hand layup. So this is an interesting process. It's easy to use. It's easy to apply for various processing techniques, and it's kind of scalable when it comes to size. So you can manufacture quite big parts, but also all the way to really small, tiny parts. So this is great, but there's also some drawbacks and disadvantages using hand layup. And one of the biggest disadvantages is that you make actually huge compromise on the fiber layup. So if we take a look at the picture on the top left, you see this kind of typical checkered pattern. So it's like kind of the carbon fiber pattern. And this is actually not ideal. I mean, it's the fabrics. Just imagine like the sweater you're wearing or a dress shirt that has like this maybe 0.90 threads, or in this case, then the carbon fibers. And this is not an optimized fiber layup. we only use those fabrics because if we do hand layup, that's the only way so workers can actually handle this material. So we do a compromise on the fiber layup, and also, and this is not listed here on the slide, we also do have a lot of material waste because we always carve out the geometry out of those fabrics. So if we now leave a little bit the manual world and go into the automated world, here on the top right, you see like automated tape laying, automated fiber placement. There are also other technologies like patch placement, filament winding in a broader context if you want. So all those technologies, they have, for one, they're automated. So usually that's to drive down costs. And to a certain extent, they give you the freedom to tailor your fiber layup. And I put now on the slide limited because it is related to the last point, only for extreme large parts. Those technologies are really just geared towards extremely large parts. So you have usually also thin shell parts, so kind of surface-like structures, which are applicable for those technologies. But we are really lacking the flexibility for smaller and thick parts. And what both worlds, the manual world and the automated world, have in common is that they are using or rely on expensive processing equipment. So I don't want to go into detail and name now a full list of processing equipment which are expensive, but in general, there's a high capital expenditure. So it's really like an invest decision for many years if you invest in a technology. And there's also the problem about utilization because just imagine you have one project and you invested heavily into equipment, and then the follow-up project is not coming, and then you get stuck with this really expensive equipment and low utilization. So now we have been talking a little bit about the material, the industries, and also a little bit on a high level on the manufacturing technologies out there. So now I want to go one step further and talk about the market. So what are the current market trends or market needs in this composite industry? So it's a lot on that slide, but I will quickly walk you through. So there is a clear market trend and a market need for better utilization of fiber layer. So that means if we use the fibers in a more optimal way, we can produce lighter parts. So that's a clear performance benefit, but we can also reduce the material used and the material waste. So there is a cost benefit as well. So if we go one step further and we take a look at the next need, which is already, we touched base on the slide before, so automation. A big trend, big need for the industry, usually just to reduce or drive down costs, but there's also another factor, and that's the human factor. So we can reduce the human error. So we have more reproducible layup or more reproducible parts. So then the next point here on that slide, there is a need for accessibility. And that's not the easiest part to explain, so it needs a little bit explanation on the context. So if we take a look now in the current industry, we see that actually this is not so much integrated, vertically integrated. So there is actually a lot of parties involved going from an idea to a final part. And there is a common trend for a lot of companies to vertically integrate, to cover more of the value creation, cover more of the value chain. And if you have everything kind of from one hand, that's what we say in German, it also reduces the friction between the individual parties, and so reduces the development times and also the lead times for going from an idea to a final part. And the last point I want to emphasize here on that slide is like the need for thermoplastic composites, or you could call it a real trend. I mean, you see that the numbers year by year go up. There's a clear trend for this kind of thermoplastic composite materials. And why are we using those materials? Because we can realize rapid cycle times to go into even higher series volume. We have superior mechanical and chemical properties compared to most of the thermoset materials. And there's the last point, that's an interesting point, remoldability. It relates a little bit back to the rapid cycle times, but also it enables recycling, which is now a hot topic, which is still in infancy, but it's also developing rapidly. Okay, so now this is like the first 3 introduction slides. We touch base on the material, we touch base on the processing technologies, and I was talking a little bit about the needs, which can also create opportunities. And that's now time to unveil the Red Series technology. We prepared a launch video for this, which was supposed to be launched at JAC, but now we're launching it here in the webinar for the first time. And before I start now the video, I just want to comment that the Red Series technology is really our answer to those market needs, which we're just talking about, to enable, or basically to create a market opportunity for you, for the user, for the customer. And now I have to switch to the video. The video has no voiceover, so I will just leave you guys to it, watch it, and I will comment and add some detail after the video is finished. So let me quickly switch now. All right, so I hope you guys can still hear me now. Yeah, unmuted just. All right, so let's continue a little bit the conversation on the RED series. In the video, you have seen that, or you might realize that it's actually not a single product. It's actually a solution. And the solution covers everything from going from an idea, from a concept, all the way to a finished part. So it starts in the software, then it goes into the physical modules. We have two. We have a build module and a fusion module. And it also incorporates the industry-grade materials with continuous fibers. And I will not go into the product details on that slide because there will be more slides to come where we dig in and talk about the individual features. What I want to emphasize on that slide is the intention, the purpose of the RED series. And that's really something important to understand, because what we want the RED series to be used for is for series production. It's not for one-off parts. And it's on structural parts, so not load-carrying structural parts. So it's not about prototyping parts. So that's kind of unique, and it's really important to understand that this technology is not for like this classical 3D printing, mass customization. It's really on structural parts for series production. And having also, we already quickly talked about integrated workflows. So having this coupling between software and automated manufacturing technology, we can really significantly optimize the parts, so we can reduce the structural weight of parts, and in most applications we exceed more than 50% weight reduction. And now we talked about this performance increase, but there is always the other side of the medallion, and that's the cost, the manufacturing cost. And that's also important to understand. Everything we worked for on this RED series is also geared towards not just being cost competitive, to actually drive down costs, bringing in this automation, bringing in this integrated workflows. So that's important to understand. So now we talked about the purpose of the RED series. And now I want to explain to you, like, what does it actually bring you? So what are the market opportunities that the RED series enables for you? And I group this in two fields. So one is metal substitution of CNC milled parts. So this is actually a really hot topic. A lot of people wanted to substitute those really thick and small, quite complex parts with composite materials, but conventional technologies, they don't really enable this kind of manufacturing, enable this kind of complexity, this kind of thick structures. And that's exactly what we are offering with the RED series. So you can go into this metal market and substitute the existing metal manufacturer, like CNC milled metal parts. And just imagine, this is actually not getting a slice of the composite market. It's actually enabling or expanding the composite market. So it's kind of creating a new market for metal substitution. And on the other side, we have the substitution of conventional manufacturing technologies. So we bring in the software, we bring in automation, we bring in this integrated workflows to really drive down the cost and reduce the structural weight of parts to get better performance. be competitive then in this kind of market. And there it's about substituting existing conventional technologies. So those are the two big market opportunities, and they are not mutually exclusive, but they're important to understand that one is about expanding the market and the other one is about substituting the existing technologies. Okay, let's move on to how we differentiate to other technologies out there. Maybe a general comment like continuous carbon fiber 3D printing or continuous fiber printing in general is actually quite hot topic in academia, but also a few already commercial players are out there. And you might also know other companies like Desktop Metal, Markforged, and Isoprint. And what I want to really explain on this slide is that the differentiation is really driven by the market focus. And our market focus is on, as I mentioned before, on structural parts, so load-carrying structures, on series production, not one-off parts. And all the other technologies out there, they're really serving a different market, which is called the prototyping and jigs and fixtures market. And the requirements for those two markets are completely different. And if we now go further, and that's why and talk a little bit about the product offering, I separated this now into materials, software, and hardware. We see that actually to serve this market, it requires a completely different product offering. So now let's talk first about our product offering. So to serve the structural composite market, we need materials which industry already knows. They need to be industry standard, industry grade. And also we have to talk a lot about supply chain, that we are not the only source of material, that we are not basically having a global supply chain in the background, and is really reliable. And we can also ensure the quality of the parts, not of the parts, of the material first, and then of the parts. And we also need to be, we have to have a competitive pricing. That's simply because if at the end 80 to 90% of the part costs are material costs, this will not enable series production. This will not accelerate the adoption of this technology. That's important. If we now go over and talk a little bit about the material offering from the prototyping companies and the jigs and fixture serving market companies, we see that there is a lot of non-standard materials. It's basically they all produce their own material, and it's not material that has been already deployed in industry or used in industry in this sense. And usually they're also quite expensive, or all of them are quite expensive because the business model is different. It really runs on the material. It's not so important on their end because it's usually one-off part, so then it's not so critical. So if we now move on to the software part, now first again talking about our end, so we have a software, we'll talk more about this on the next couple of slides, which has like a high freedom to operate or tailor those fibers. So you can really steer the fibers, you can make or change your layup sequence, etc. And we also have this commercial FEA integration. And this is important because once you simulate and you have a high freedom to tailor those fibers, you can find an optimal design. And that's what we are enabling. And that's important for structural parts because you have to have a competitive advantage on the performance side, and you have to have a competitive advantage on the cost side. And now talking a little bit about the software from Markforged, Desktop Metal, and Isoprint, it's really geared towards being easy to use. So I sometimes call it the black box magic because it's easy to use, one click of a button, but it kind of puts fibers into a part just because of the sake of putting fibers into a part. It's not really optimized. And the last part, hardware, on our end, we are relying on a two-stage process. So we have a printing process and a post-consolidation process. And you have seen this on the slide before, where we have two modules, and we'll talk more about this later on. And this is really unique and it's really important so we can ensure the quality, the part quality, which is required for series production of structural parts. And last but not least, on the hardware side for the jigs and fixture, the prototyping domain, all those companies, they're really just offering a printing system. It's okay because their market does not require any post-consolidation, any enhancement of the part quality. So for me, it was important to showcase on this slide that it's really about the market, and the product offering kind of relates or basically answers to those market demands. So this was the first part, the first section on the introduction side, introducing the RED series, and now we want to go into the details. I think I actually have to, make my sound. I had to put my sound off, so I don't always hear like the questions coming in. Okay, so now it's time to go into the next part of the presentation, which is the product details of the RED series. And we'll start with the materials. So industry grade materials we have at the moment, we will offer two materials. One is a PA and the other is a PAKK matrix system or base system with high fiber volume content, 60% fiber volume content and continuous fibers. So you see that we have really high performance materials, high strength, high modulus, and that's just like the beginning. So basically the tip of the iceberg. We will gradually add new materials to the portfolio, but that's the material offering we have right now and how we launched the RED series. Now, important also to understand is that we are not a material producer. So what we are doing is like we certify material, industry grade material that's already on the market and make it accessible to be printed in our RED series system. So that has many different advantages. So for one, you already know the material you're using with the RED series, but we can also kind of rely on this global supply chain. And we might dig in later in the question phase, but I will not talk more about this on this slide now. It's an interesting topic. So now the next 3 slides are actually on the product itself, and it's structured in a way in the workflow. So we start in the software, then we go into the hardware part, all the way to the final part in hand. So let's talk about the Fibrify software we are offering. And maybe before I go into detail, important to understand this here, it's about digital prototyping. So it's about like generating a digital twin that can be simulated, where you can have an environment where you don't always make a new fiber layer, but with a new design. You physically produce the part and then you test it, and then it's kind of a trial and error approach by engineering knowledge. So what we offer with the RED series is digital prototyping. So basically, you find your most optimal solution in the software before you then go into the physical domain and produce the part. So let's talk a little bit about the details. So Fibrify software, there's actually twofold. So we have a Fibrify design suite where you have a full freedom to design or orientate the fiber, to choose your layup sequence. And there's also direct integration to commercial software, commercial simulation software, so FEA software, where you can then, which you can then basically use to find your most optimal solution. The other side of Fibrify is the production environment. So the production environment is, just imagine it as the tool where you can manage the entire workflow. So you can manage your printers, you can manage your part library, but you can also like monitor like the process on the different printing parts, on the fused parts. It also collects all the data and or basically it monitors all the processing data and in general all the data, so you can have always a data set to analyze maybe your parts, maybe your process, and that's really important. So it's a cloud-based system. So let's talk a little bit more about the FEA integration. So we are really proud to, and we just introduced this last week with Ansys, that we partnered up with Ansys, and they really, it's kind of a unique partnership where we enabled a direct link from our Fibrify software to the Ansys ACP module. So it's the composite pre-prep post module, where you can have then a simulated, basically where you can generate a part which can then be simulated for structural simulations, but it can also be done for thermal simulation or processing simulation. And this is really important that you have this direct link, because this enables you to also iterate and do optimization loops to find your most optimal design. And we're really the only technology that can offer this on the market. So now let's go further into the physical world. So once you have found your most optimal design, then you can apply our additive fusion technology, AFT, which is it's a two-step process, as I mentioned before. So we have a build module and you have a fusion module. The build module, that's where you actually have the automated fiber layup. So you can just imagine it as the execution of the software. And it's enabled to do plastic printing and carbon fiber printing. So you can have this hybrid part, which are quite important if you go to really complex geometries and architectures. The build volume is fairly big for a desktop-sized machine, so we are 350 millimeters by 270 millimeters by 200 millimeters in build volume, and the system is comprised of a heated print and material chamber. And now, what comes from the build module is actually a tailor preform. That's how I usually call it. And this goes into the fusion module. In the fusion module, what it does, it applies pressure and heat, so it increases the part quality, the consolidation quality. So we're talking about reduced residual void content and also higher interlaminar strength. And what's really unique about this fusion module, it's a completely modular system. So we use rigid tooling to provide the shape and the geometry of the final part, but it's a completely modular system. And at the end, what you have to change for a design change is just the insert, like literally the very last thing that actually provides the shape and the geometry. And what's also unique about those inserts, we will have a direct link, just imagine as a click of a button in the software. Once you have found your optimal design, you click that button and we will provide you the inserts for your fusion module. So we will ship those metal inserts and then you insert them into the fusion module and then you can produce your parts or fuse your parts. And the last point, it's also important to understand that this fusion module is completely connected to the Fibrify software. It's the same for the build module, where you have full process control and full data monitoring of your process. So you can also have a log, so you can always look back into the history, and monitor and also this is important for quality control and documentation. Okay, and what comes out of the fusion module is your final part. So you see now here is just an illustration of the part we have seen before. This is like a automotive motorsport bracket. I don't want to go into the detail of the application, but it's important to understand that what comes out of the fusion module has an extremely low residual void content. So we're talking about something below 1% void content, and that's important because that's the only way to go into the structural applications, into the series and also series production applications. And the other two aspects, so high geometrical variance, low geometrical variance, not high. So you have low tolerances and you have a higher reproducibility, which is important, again, for series production of structural parts. In other words, for actual composite parts and not prototyping plastic parts. Okay, so there are two more slides now on this middle section. One important thing, and that's really interesting to understand. So what we can do with our technology, so this additive fusion technology enables the combination of multiple parts in this fusion module. And this combined, or this basically having this kind of feature combined with software we are developing enables the user to split up a part into multiple subparts, which you can then individually optimize the fiber layer. You can then combine them into a multi-part assembly, go again into the FEA software, into Ansys, make your structural simulation or thermal simulation, and enter this iteration loop. So to enter this digital prototyping loop, and once you're satisfied, then you print multiple parts, you assemble them, put them into the fusion, and you have a really highly structurally optimized part with really complex fiber orientation. So not just in plane, also out of plane. And that's really unique because additive fusion technology enables the combination, and the software enables this kind of complex fiber architecture on the design and simulation side. Okay, and this is really relevant for metal substitution, and we will have, and I have also one part here. This is like aerospace hinge. It's actually from a helicopter door. You see that here is the part you see also on. I'm back now. So this is the part you also see now on your slide. And you see now that for this kind of case, we want to talk a little bit more about the numbers, about cost and about weight reduction potential. It's a series production part, so we have around a series of 1,000 parts a year. The material we are used here now for the metal substitution is carbon fiber PAKK material. And if we now look a little bit at the numbers, we could reduce significantly the cost of the parts, so around 30% for this kind of series volume. And we can also significantly reduce the weight of the structural weight of the component by around 80%. So you see, that's actually quite unique. It's not just about the performance increase, it's also about the cost increase, about being cost competitive and even reducing costs in series production. So that was just one example we have now. We will present just this case now, but over the next couple of weeks and months, we will like continuously upload on our webpage, which is, by the way, now should be online, the new webpage, where we will continuously upload new use cases, always focusing on like comparing it also our technology to conventional technologies, and then having basically the full analysis on the cost side and also on the lightweight potential side. Okay, so now we are entering the last part of the presentation. I think now we're 30 minutes in, so I think we're good on time, so to still have some Q&A time at the end. So the Red Series subscription, now we're talking about the product offering. And for us, there is a clear goal. We want to make high-performance composites more accessible to you by providing a solution that enables you to quickly go from an idea to a final part, to have like this fully integrated workflow, and vertically integrated workflow. And we also want to always provide to you the highest productivity by having state-of-the-art technology. And that's important to understand, because this kind of technology, automated 3D printing, continuous fiber printing, this is really super quickly evolving. So we always want to ensure that you have the newest technology and the highest productivity. And the last part, and that's what I mentioned a little bit earlier in the introduction part, it's really about enabling you to move into new markets, to bring you more market access. So basically, so you have higher potential to enter new markets and generate more revenue for your company. And so now really talking about the Red Series subscription. So that's what our product offering looks like. So we have software, we have hardware, and we have engineering service in this Red Series subscription. So it's important to understand that we just don't want to ship you hardware and send you software and then you can just use it for whatever. For us, it's really important to have a relationship, to work with you hand in hand and helping you to go quickly from an idea to the final product, helping you to understand the software better, educating your engineers on the solution, on the technology, so you're really efficient in deploying it and employing it on your parts. What's important also to mention that there is customer support. Customer support has different angles here. So for one, it's always what I mentioned before. We want to ensure that you always have the newest technology. So there's software updates, there will be hardware updates, there is maintenance on the systems. Basically, the systems are always operational and you always have the newest tech, the newest technology to be at the highest productivity level. And also having direct contact to customer support, so you don't have to call or many times and no one is answering, or sending many emails. So you have a direct point of contact. Outside of the subscription, but also important for the product offering, we have the materials. And I mentioned before, or we talked a little bit about materials. So here it's about guaranteeing the supply chain, guarantee the prices, and guaranteeing the quality. And that's what we do. And you have now the two materials in the portfolio, but this will also grow over the next months and years. And the total, I can mention this at this point. So the Red Series subscription, it's a 2-year subscription, and the basic plan for the subscription is 75,000 euros a year, and having the software, hardware, and engineering included, what you see here on that slide. And we can talk more about this in the Q&A section if there is a question. So now moving on to why subscription, because it's a little bit a newer concept, so maybe it needs a little bit of explanation. So that's I just want to talk quickly about subscription. So there are actually three angles we listed here. So one, maybe I go quickly through all of them. So we have performance. Performance here, it's what I mentioned before. It's about having always the latest features, the newest technology. It's such a quickly evolving field that you actually don't want to invest into a technology. You don't want to make now a buy decision for a 10-year investment in additive manufacturing, because it's so quickly evolving. So you will always have the newest update. And that's what we are enabling with the subscription model. And then going into the customer support. On the customer support, there are different things, but one is really that we have a close relationship. So it's about going quickly from the idea to the final product. And we want to help you. We want to support you. That's why on the slide before you have seen the 1 hour in the basic plan, the 100-hour engineering service included into the subscription, because we know it's important to go from the idea to the final product. And then there are other aspects like direct service, contact. I mean, that's what I mentioned before, like you have a direct point of contact at 90 Lab side. And we also have, this is interesting, the predictive maintenance feature. You hear this a lot now, it's kind of a buzzword, but we can really do this because our software enables us, we have access to how much you use the system, and we know like about the wear of the parts, like let's say the pressure foot or the printing, anything that, you know, has like wear, we can predictively substitute and already send you spare parts before it actually, the machine shuts down and you are left with no machine to produce parts. So the last aspect, financials, maybe even it's always talking about costs, but it's also important to understand that this is like, if you have a subscription, it's a no invest decision. So it can come from the operational budget, and that's important. So it's on our balance sheet, it's not on your balance sheet, and that's important to understand. And maybe also on that end, important, I mentioned it quickly before, you don't want to make an invest decision that's 10-year plus. That's like the conventional manufacturing technologies. They all have this kind of 10-year plus investment decisions, and that's what you don't want to have in this highly paced environment. And it gives you really a lot of flexibility to evaluate the technology if it's something for you, for your series production for the future. And if it's not, then you're not stuck with the technology for the next 10 to 15 years, and it's on your books, and you lose a lot of money on that end. Okay, cool. So talked about subscription now a lot, and about the product offering. I have 2 more slides to just illustrate a little bit how this works. So to be really concrete, the way we work with customers, we enter first a feasibility study, and then we enter into the subscription, Red Series subscription. So with some of the guys now in the webinar, we're already in the feasibility study or past the feasibility study. But for the other people that joined now the webinar call, it's important that there we do, in the feasibility study, we do a technical feasibility and economical feasibility. So it's a little bit about the business numbers. And if there is potential for your application, for your industry, then we enter into the Red Series subscription. And this is also usually a 2-step process. In the beginning, we help you to set up the Red Series, we ship you the Red Series, we help to educate your engineers and kind of, you know, screen the portfolio of applications, and the application engineers will also help to optimize the part before we then transition into the production state. And in the production state, we will support, obviously, on the, we will support when you have questions or when you need help with the system. But we also will ensure that there is a continuous material supply. We'll offer this tool service. So this is like this one click in the software to get those metal inserts for your fusion module if you have a new design. And we will have continuous maintenance and technology upgrades. So you always have to use technology. Okay, so last slide. Just one more thing about this feasibility study. So this is like the first step in. So I think it's important for you guys to understand like how this actually is, or what this is. So it's basically there's input output, and the input what we need for this feasibility study from your side is that ideally step file, so a part design, and as much data on the part as possible. So production volume, boundary conditions, so like load cases, etc. Maybe also thermal conditions, as much data and information on the part as possible, because that really enables us to put together what we sometimes call an executive summary. So what we will, like our output from this feasibility study for you, is then a recommendation on the material side, and we have an analysis on the different potentials, lightweighting potential, cost beneficial, cost potential. So how much we can drive down the cost in manufacturing for the different series volumes, etc. And this is like kind of like a nicely packed into this executive summary. That's what we will provide to you. And this is like the first step in, and I want to encourage you to kind of enter this discussion with us so we can enter this feasibility study and really see if this technology, the Red Series, makes sense for your applications in your industry. Okay, and yeah, for this year, we cannot work with all the customers that come in and want to work. We were quite limited on the resources. So yeah, don't lose time to contact us. So it's a little bit on the first come, first serve basis. And this was my last slide. I think I've seen, or I don't see it on my screen, but I see like next to me that there is actually a lot of questions coming in. And I think now Chester has the chance to speak up and moderate a little bit the questions, and we can answer them. Yeah.
Yeah, sounds good. Yeah, thanks a lot, Martin. Yeah, we had already a lot of questions actually come in during the presentation. Please
I've just heard it. Like there was always this click.
Exactly, there were like all these sounds coming up. Yeah. So feel free to post any more questions you might now have. If like we'll try to get through as many as possible, but if we don't manage in this Q&A, then we'll definitely follow up in an email or on a call later on. Maybe to start, because there were a lot of questions on material, and both on kind of the material form that we supply, as well as on the thermoplastics. Could you say a few words about what material form it is, and secondly, why we, for example, chose to go for PEC and not for PEEK, and what kind of the material roadmap is?
Okay. Also quickly go back to the slide, so we can have a little bit an image as well. So yeah, okay, first talking about the feedstock material itself, so about the, let's say, the physical side of it. So we are using for the Red Series technology tapes, which are really like slender slitted tapes, which we can provide, and that's kind of like the unique part of it, because we make this process, our Red Series process, accessible to those kind of materials, like the slitted tapes. And tapes is a common material in the market, so we really have kind of access to this already broad spectrum of materials. And important is that it needs to be a certified material too, so we can ensure that it's reliable and that you don't have any struggles in the production. So that's why we have only the two materials for now in the material portfolio. And so that was a little bit on the first part, I think, on the feedstock size and material. And now talking about...
Yeah, maybe let's say on this topic for just 1 second more, because I see a bunch of other questions come in.
Yeah.
Can you say something about the cross section of the filament, and what like the number of fibers is that's in the filament?
So approximately the systems we are offering here now as the first materials in the portfolio, they have around 2K. It's a 2K filament. So it's quite a slender filament, gives you a good resolution, and over the years we can even go smaller, but we also can go higher, and there will be a portfolio of materials also on the side, because if you don't have so high resolution, you might go with a 3, 4, 5K material at the end.
Right.
And I think there was also the question on why PA and why PKK materials, right?
Yeah, exactly.
Yeah. So in general, like depends a lot on the application. So PA, it can be used a lot in automotive or leisure applications. It's a little bit more about the thermal stability sometimes, the limiting factor, and that's where the PKK material comes in, where we have a high thermal stability up to 160, 70 degrees Celsius continuously. And we will also gradually add materials that are then even geared towards medtech applications and other really specific applications. But in the beginning now, we have the two materials, and it's a lot about the thermal requirements of the application which you pick, and a little bit also about the mechanical performance, because the PEC material with the little bit different fiber is really outperforming the PA system, but it does not require the PKK system for all the different applications. But we will keep you guys posted, and I think there will be a lot of also webinars on material. We will launch webinars on the software as well. So I think there will be a lot of more information coming on what kind of materials we are planning to use in the future and what the materials are capable of right now.
Yeah, and we'll also upload the material data sheets on the website, or they might actually already be online, or we'll send them after the webinar. So you'll see all the data with respect to what kind of systems and what the properties are.
And the webpage should be online right now, so I think you can already access it.
Exactly. Then there was also an interesting question about the fiber volume content.
Yep.
Is that in the material as it goes into the build module, or is this in the final part?
Okay, that's a good question. Not super easy to answer because we have to go a little bit technical. So the system is capable of printing just plastic, just neat plastic, but also carbon fiber reinforced plastic with this high fiber volume content. So this 60% fiber volume content is really meant for the feedstock material itself. The final part, it depends on how you design it. If you just use in your Fibrify software and you design just carbon fiber, the final part will have 60% fiber volume content. If you have certain sections where you decide to use plastic, because you don't want to kind of waste this high performance material in sections where you basically just place fillers, they use the plastic. And for some certain geometries, you also need a little bit of neat plastic to kind of bridge gaps or, sharp corners, etc., to mitigate the stresses. So long story short, the final part, in most cases, the total fiber volume content of the final part is lower than 60%. But that's, I think, not the important aspect. The important aspect is that you have the fibers in the part in the most optimal way. That's what it's all about. It's not about the final part fiber volume content. It's about having the fibers in the most optimal way placed into your complex geometry.
Mm-hmm. All right. Yeah. Thank you. There were also a couple of questions about the integration with Ansys, or the kind of the direct export towards Ansys. Mm-hmm. There was, for example, a question what the file format is. Rene, can you say something about that?
Yes. The export interface in Fibrify supports the composite CIE format. That is a vendor-independent format that was specified to translate composite parts between different FEA applications. I have quite an echo here on my side. And then the import in Ansys reads directly this file with minimal interpretation, so you have a very precise description of the final part, which is almost a one-to-one representation that can be used for structural or thermal simulation.
I think there's quite a big echo from Rene. Maybe if you can try with earplugs for another one. Mm-hmm. I'm sorry. I think I'm not sure why that happened. But maybe to summarize, so there essentially the Fibrify software generates an HDF5 file format, which can then be directly imported by any commercial FEA software. And the like special collaboration we have with Ansys is that we make sure that it actually works well, and also that additional data can be sent so that you don't have to spend a lot of time in the pre-setup of the simulation.
Yeah. So it's really about the pre-processing. I mean, if people are into simulations, it's really about the pre-processing going from our fiber tool into the model generation in the simulation environment. Yeah.
Right. Okay.
I think Rene is back.
Yeah.
You want to try it again, Rene? Just maybe. Do you want to add some comments, or are you good?
Can you hear me?
Actually, that's good. Yeah.
Yeah, we can hear you.
Okay, thanks. So yeah, this vendor-independent format was really designed to exchange composite parts between different CAE applications. And the novelty is that it's an automated process between the Fibrify application and Ansys. So there's minimal input and interpretation needed to transfer the final part into a simulation environment that allows you to verify the final strength and stiffness, but also to run optimization. And that is very important, because without these automated interfaces and robust interfaces, you can't reach the full potential of these new printed parts.
Thank you, Rene.
Yeah, thank you. Great. So then if we move on from simulation to the actual, like the physical parts, to building them, there were more some kind of business side questions, for example, on the fusion unit. Well, first of all, how big are the parts that we can manufacture between the build module and the fusion module? And secondly, what are the equivalent tooling costs that are required on the fusion side?
Okay. Yeah, it's a good question because the fusion concept is quite unique. I cannot go into all the details about the modular system because we would have to sign an NDA first, but I can comment a little bit about on that question. So in general, like the fusion module is capable of producing the parts which can be manufactured with the build module. So it could be a fairly big part. About the tooling cost, this is a little bit dependent on the size of the part.
Can you give an example, for example, for the bracket, like the aerospace?
So for the bracket, I mean, not sure if the bracket itself is actually, you have seen maybe on the slide, it's just 20 grams. So it's a fairly small part, it's like the door hinge for the helicopter. So for this kind of system, it will be like a few hundred francs. So this dollars, if you want, or let's say also a few hundred euros. I'm always confused here about the currencies, being in Switzerland and all. But I think this part at the end, it will be around then, let's say 300 to 500 Swiss francs or euros to produce. So you see that there's a massive difference between producing this part with a conventional like press technology, which then is in like a few thousand parts to have a tooling.
Right.
Yeah.
Great.
And it's also with this having a really convenient interface. Start just clicking on the button, and then you get the inserts delivered, and you're ready to go, or good to go.
Mm-hmm. Great. Then there were also some questions about applications and partnerships we have with different customers. When do we plan to release some applications and partners? Is there something in the pipeline? Is there something we can say about that?
So you mean like making collaborations and actual customer parts public?
Yeah, exactly. For example, and also to back up, the business case and the cost structure behind it. That we kind of give more clarity to what kind of parts have what kind of cost structure behind it.
Okay, it's a good question. So what I mentioned before, like over the next year, and I mean we'll continue this for the years to come. We will always have new parts uploaded on our webpage or in our marketing materials and our sales materials, where we talk about real application, customer applications, and the business case behind it. Sometimes a little bit hard to mention the actual customer. That's because most of the parts, almost all of the parts, are on the NDA. So on one hand, we cannot disclose those customers, but I think here it really makes a lot of sense to do a feasibility study together, because there we can really take your part and make the business case analysis on your part. Yeah, I think that's one way forward. So it can be inspired by the cases we publish, but it's really also, I think, usually a good idea to really just talk it through on one of your applications. Mm-hmm. And we generate this executive summary for you.
Okay, thank you. There were some more questions on what kind of parts are manufacturable, both in terms of how complex can the geometry be, but also on what the fiber layout, if it has any limitations. Like how, for example, could an engineer start designing such a part? How many parts can it be made out of? Is there like a minimum curvature radius, for example, for the fibers?
Mm-hmm. Okay, I think it's actually a lot of different questions in one question. In general, so it would be a little bit naive to say like there's like every single geometry that's possible to generate or to design and simplify is possible to actually then print and also fuse. So there's always some limitations. So on the radius, maybe start here. So we can always ensure below 5 millimeters a good fiber layout. You can print sharper angles and sharper radii, but obviously going with a 2K toe or tape in to the process, there will be some fiber distortion. So it's always a little bit a trade-off of what you can suffer on the fiber orientation. Mm-hmm. When it comes to this,
what would you say in terms of radius is like kind of a good number?
I think if you really want to have low fiber distortions, around 5 millimeters, it's a good number. Mm-hmm. If it's below 5 millimeters, there's always also a good question why, because fibers going around sharp corners, you really kind of suffer the mechanical performance. So there's kind of a big question: why would you even do this? Mm-hmm. And you will see in the software, if you simulate it, that it maybe makes no sense. But I think that would be a good house number. Coming back to how many parts can be assembled if you use this additive fusion technology, about what I explained about this complex true 3D fiber orientation. Technically, there is no limitation on how many parts, but you just have to imagine that you also have to put the parts together. So there it's always about keeping the parts minimal, but still having like this most optimal design, you know, for your load case requirements.
Right. Okay. Thanks. Then I think a super relevant question in terms of the product being available both on the Ansys side, so the simulation, and on our side, Red Series. Maybe or let's if we can start. Can you when is it available? When can people expect to be able to manufacture parts with these machines?
Okay, so when the product will actually be delivered. So maybe it's actually there are two things. One is the physical print units, the build module and the fusion module. The physical units will be available in September. So we will ship the first units in September. The software, let's say the beta version of the software, we can offer already earlier. So if we enter into the subscription phase, we can in a way start right away offering you the software to the current state, and then work together on the software as well, or working with the software on your application parts. And that might already start in June. Yeah.
Okay. Great. Rene, do you want to say on your side what the plan is?
Yeah, the enhanced interface should be available in the next release. That will or should be available in July, August this year.
Okay, great, Rene. Thanks.
Thank you. Thank you. Let me just go through, see if there are any other questions.
Actually, not so easy to screen those questions.
Right. So what about lattice structures or cavities in parts?
Yeah, I was looking forward to this question. So it's important to understand that we can produce quite complex part architectures, but it's also important to understand that those architectures need to be cannot be hollow. It needs to be a monolithic structure, and that's maybe because we talked about the fusion module already. You know, applying heat, applying pressure. You can imagine if you have an internal structure, like a hollow structure, that it will collapse, right? And you will suffer on the deformation on the geometry of the part. But here, maybe go a little bit further, it's actually also not necessarily required, because you can really go for a lattice structure which is not internally hollow, but you know the global structure is hollow, and basically your truss members are monolithic, and that's what we can realize as well.
Okay, thank you. What about minimum wall thickness of a part? Yeah.
So there's actually two answers to this question. One is like the printing height we have right now. It's around between 0.2 and 0.3 of a millimeter. So it's fairly thin. So if you just use one layer, technically you can do this. I mean, there are not maybe many applications for that, but technically we could produce parts that are like around 0.2 of a millimeter. And if you go a little bit further, you could even use the fusion to kind of press it slimmer. So it could be even more slim. But it's not something we really built the machine for, or this entire technology for. So I would say a good house number for a thin part is more around 1 millimeter. Right. Not saying it's not possible, but I think most applications, all applications we see right now, they are thicker than. And kind of a unique feature is more on exactly the opposite side, going into applications where you have really thick parts, which are not really easy to manufacture using conventional technologies. Yeah. So you go into this metal substitution field.
Right. You mentioned these different application fields. What application fields do we mostly work with at the moment, and do you see as most relevant?
So you're talking about industries, right?
Yeah, exactly.
So industries like one clear focus is on aerospace, but also medtech and automotive and leisure applications. So in the leisure application domain, I would also count luxury applications. So you could imagine something that, you know, jewelry related, all this kind of applications could be also interesting, but they are from the requirement perspective are similar to the leisure application. So that's why I always group them into the leisure slash luxury domain. And automotive is a little bit more on the high end, so it's more about motorsport application, less about VW Golf application. I think that we might get into that, but that still takes some years, just also on the material side to drive down the cost.
Right. Okay, thanks a lot. I think we've covered many different topics during this hour. I think it's time to wrap up. If there are any closing remarks from Rene or from Martin, if anything else to add?
You want to go first, Rene?
No, nothing from my side.
Well, for joining.
Thanks a lot for joining, Rene.
Yeah.
Thanks. Yeah, on my side, yeah, it was a great pleasure to introduce the Red Series to you. I'm really looking forward to also have like a physical contact with you guys and talk more about actually applications and the Red Series technology. And yeah, don't hesitate to contact us. I think we will also follow up on the questions we couldn't answer, probably tomorrow then. And yeah, looking forward to staying in touch.
Exactly, and hopefully physically meet at Jack in May or even before that.
Yeah.
And yeah, don't hesitate to.
Yeah. Also, kind of now,
and check out the website. We have a new website.
Yeah,
check it
that's
out.
what I just also wanted to say. So check out the new webpage, and we also have the video, like the launch video on YouTube. So if you want to show it to other people as well. Okay, great.
Great. Thank you very much.
Thanks.
And have a great rest of the day.
Thanks a lot. So we'll go offline now. Ciao, ciao.
Bye bye.